Good morning again. This is Dr. Jingbo Louise Liu. So today we are going to start your chapter 8 about electron configuration and chemical periodicity. In this chapter, we are going to discuss 4 different key topics. The first one related to the characteristics of many electron atoms. The second topic, the quantum mechanical models and the periodic table. The fourth one about 3 different atomic properties. They are atomic size, ionization energy, electron affinity. The last topic is not our key point, but we need to briefly know about chemical reactivities. So first one, let's recall our 4 different quantum numbers. The first 3, principal quantum number, angular momentum quantum number, magnetic moment quantum number, describes the orbitals. The last one, electron spin quantum number, discussing the electron spin direction. N is used to denote principal quantum number. It varies as the positive integers from 1, 2, 3, all the way to 7, correlates to your periods in your periodic table. This N represents the size of your energy of the orbitals. The second angular quantum number, angular momentum quantum number, smaller l, can be ranging as the integers from 0 to n-1. The orbital shape will be defined by this smaller l. If you have l is 0, you have the s orbital. L is 1, p orbital. L is 2, d orbital. 3, f orbital. We call them s, p, d, f orbitals. And a smaller ml is used to denote magnetic moment quantum number. This number changes as the integer from negative L to 0 to positive L. It represents the orbital orientations. Also tells you the number of the orbitals. Your S only have 1 spatial orientation, only have 1 orbital. P, you have 3 different spatial orientations. You have px, py, pz, 3 orbitals. D, you have 5 orbitals. F, you have 7 orbitals. The very last quantum number called electron spin quantum number, ms. This value can be only positive 1/2 or negative 1/2. It represents the direction of your electron spin. The electrons have the maximum number in the orbitals. In each orbital, you only have 2 electrons. You have 3 electrons. Your p orbitals can host up to 6 electrons. Your d orbital can host the maximum electrons of 10. F orbital at most 14 electrons. In order to distribute the electrons into the atomic orbital, we need different rules. First of all, the electrons in the atom is described by a complete set, described completely by a set of 4 quantum numbers, N, L, ML, and MS. Is called the quantum number set. The first 3, as we stated, describe the orbital. The fourth one describes the electron spin. You have 4 different rules which guide us to allocate electrons into different orbitals. Alpha build-up principle, Pauli's exclusion principle, Hong's rule, Madelung's rule. The alpha principles, also called build-up principles, states the electrons enter and fill lower energy orbitals before higher energy orbitals. Pauli exclusion principle states no 2 electrons in the same atom can have the same 4 quantum numbers. In other words, an atomic orbital can hold a maximum of 2 electrons, and these 2 electrons must have opposing spin oppositely. One spin up, another one must be spin down. One clockwise spin, another one must be counterclockwise spin. The Hong's rule states, when several orbitals of equal energy are available, such as px, py, pz, 3px, 3py, 3pz, as a given subshell, like we mentioned, electrons enter into different orbitals with parallel spin. We are going to show you the nitrogen. The electron occupation in the different orbitals of your nitrogen. Maid-Lang's rule, also called N plus L Aldrin rule. The Maid-Lang's rule states the orbitals fill with electrons as N plus L increasing. If the value of N plus L for that orbital is bigger, the associated orbital has higher energy, will be occupied afterwards. For example, at 4s and 3d. 4s has N, which is 4, L is 0. 4 plus 0 is 4. For your 3d orbital, its N is 3, L 2. 2 plus 3, 5. 5 is bigger than 4. Therefore, 4s orbital has lower energy than the 3d, and it gives the periodic table its characteristic appearance, such as you have group 1, 2, and then 13, 14, all the way to 18, and you have the group 3 or 3b to 12 or 2b. That's what you are going to find from your periodic table. To summarize those 4 rules, Pauli's exclusion principle states no 2 electrons in an atom can have the same set of quantum numbers. 2 electrons occupy the same orbital, they must have opposite spin. Hong's rule states when several orbitals of equal energy are available in a given subshell, electrons enter with the parallel spin. Electrons are not going to be paired, they are unpaired. The Affable build-up principle states electrons enter and fill the lower energy orbital before higher energy orbitals. The Maid-Lang's rule, also called N plus L Aldrin rule, states orbitals fill with electrons as N plus L increasing. This rule explains why the 4s orbital has lower energy than the 3d orbitals. This diagram showed you the subshell filling orders. From top to bottom, the energy increases. From left to your right, energy increases for that orbital. So the splitting of your levels into sublevels, such as for your period 3, so you have 3s, 3p, 3d. So you have the third period, you have 3 different orbitals. So you split it into the subshells of different energy. Splitting is caused by the penetration and its effect on the shielding. For a given N value, the lower the lower the L value indicates the lower energy level. For example, 4s, 4p, 4d, 4f, S has lower energy, P followed by higher, D much higher, F has the highest energy. The ordering of the sublevel energy if the N is the same, S lower than P, lower than D, lower than F. If you have the same L, such as 2s, 3s, 4s, the bigger the N is, the higher the energy for that orbital is. What you also found from this chart, the n value is constant horizontally, such as 2s2p, 3s3p3d, 4s4p4d, 5s5p5d. The n keeps constant horizontally. The L value is constant vertically, 1s, 2s, 3s all the way to 7s, 2p, 3p, 4p, 5, 6, 7p's, and including 3d, 4d, 5d, 4f, 5f, etc., etc. Your n plus L, this n plus L, principal quantum number and angular momentum quantum number, the sum is constant diagonally. If you see the diagonal, so you can do the calculations. So how do we distribute electrons into the different orbitals? You have two key terminologies. One of them is called the electron configuration of atoms. The second one called the orbital diagrams of the atoms. So let's take a look about electron configuration. We need to know key points. Point 1. The electron configuration shows the number of the electrons which are indicated by a superscript in each subshell, such as this number 5, the blue color, the number 5. The electron configuration describes the arrangement of the electrons in your atom. For example, one of the elements has electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 2s2, 3d10, 4s and then 3d, and then 4p6, 5s1, 4d5. So in this electron configuration, you are going to understand the quantum set, the quantum number set for a particular orbital or particular electron, particularly for 4d5. For some of the electrons, your n is number 4, your L for d orbital is 2, your ML can be varying from -2, -1, 0, +1, +2. Your MS can be +1/2, can be -1/2. For this 4d5, particularly for this denotation, number 5, the blue colored number, represents the number of the electrons assigned to the designated orbital. In this case, it's d orbital. And the red colored letter represents the orbital shape, which is d. It's a different types of orbital, S, P, D, F. So this orbital corresponding to the angular momentum quantum number. And then the number 4, the black colored 4, represents the electron shell. This is in the 4th period. So this shell related to the principal quantum number n. The orbital diagram shows how the electrons are distributed among the different orbitals. Each orbital is represented by a parenthesis or a box or a circle, and the electrons are shown by the arrows written down either as an up spin or down spin. Depends on spins again. For example, your fluorine. So go to your periodic table, find the atomic number, which is 9. This fluorine, when it's neutral, the number of electrons is also 9. So you are going to place 9 electrons into 1s, 2 of them, 2s, another 2, 2p5. So that's how you introduce the electrons into the different orbitals. This diagram is called the orbital diagram of your electrons. Next class, I'm going to show you how to apply the different principles: Alphabet build-up principle, Pauli's exclusion principle, Hong's rule, and Madelung's rule. From there, we are going to build the orbital diagrams and electron configurations. Thank you so much. You have a beautiful day. Stay safe, stay healthy.